So, we are done configuring your OSPF. Now let's try to configure RIP version 2. Now, why version 2? RIP version 1 is not good because it only supports classful routing and uses broadcast to share information. Version 2 is stable and supports classless routing. No need to specify the command no auto-summary. This uses multicast to share the information, reducing the burden on the network devices that do not need to listen to RIP updates. So let's proceed, and I'll give you the checklist of RIP. Now first, RIP doesn't need any AS number, name, nor process ID like the first two protocols discussed. You just simply need to advertise directly connected networks. If you want to make sure if the command is properly configured, use the command show IP route and you should see an R on the left side, and show IP protocols to check the routing protocol used on the topology. Now, I have here a GNS tree and just a basic configuration of RIP version 2, and I'll just gonna start this one. We're done with your RIP configuration laboratory. Let's go with your SIMLET. Now here is your network topology, and I have here the questions. So let's go with question number 1. Server 1 and server 2 are unable to communicate with the rest of the network. Your initial check with system administrators shows that IP address settings are correctly configured on the server side. What could be an issue? A. The VLAN encapsulation is misconfigured on the router subinterfaces. B. The router is missing subinterface configuration. C. The trunk is not configured on the layer 2 switch 1 switch. D. The IP address is misconfigured on the primary router interface. So now let's check this router and let's read the configuration. Enable, then let's just type show run to see the whole configuration of server 1 and server 2, which is on FA02 and on FA03. So if you're gonna see here, it's configured in a virtual subinterface. So this is called ROAS, or router on a stick. So two IP addresses belong to two different VLANs that are encapsulated in one interface. So as you can see, since this is .100, so the address is .100, and so the encapsulation should be on 100, but this one it's on 200, and the 200 is on the 100 encapsulation. So on that you will see the errors or mistake from this one. So the right answer for question number 1 would be A. The VLAN encapsulation is misconfigured on router subinterfaces. Now on here, you will see the third file. So let's proceed with the second question. Routers in the user main office complain that they are unable to reach internet sites. You observe that internet traffic that is destined towards ISP router is not forwarded correctly on router 1. What could be an issue? So as you can see here, here's the result of R1. R1 tries to ping 209.165.200.255. Now the first choices would be the next hop router address for the default route is incorrectly configured. B. Default route pointing to ISP router is not configured on router 1. C. Default route pointing to ISP router is configured with AD of 225. And D. Router 1 configured as DHCP client is not receiving default route via DHCP from ISP router. Now let's check and let's go to R1 to see the whole configuration of what is going on, why it is not pinging the ISP interface. Now here is R1, then let's just click it, go to the configuration, type enable, and then let's just show run. And as you can see here, it doesn't have any IP route, which means that there is no point of passing the address to an address, which means that in this topology you have to create a route so that the end devices can go to ISP. But here in R1 you can see that there is no IP route in here. So let's check with the show IP route, and let's check if let's check if which traffic it will pass by to go to the address 209.165.201 network. So as you can see here, only 10.172. And as you can see here, there is no configuration on R1. That is why the router or the device cannot go to the ISP link. Now let's go back with the Word file and let's check. So the right answer for this question would be B. Default route pointing to ISP router is not configured on R1. So the answer is B. And here is the explanation for that one. Then let's go with question number 3. Examine router 2 configuration. The traffic that is destined to R3 LAN network sourced from router 2 is forwarded to R1 instead of R3. What could be an issue? So as you can see here, here's the trace route. Source and that one. Then the choices would be RIP version 2 enabled on R3 but R3 LAN network that is not advertised into RIP version 2 domain. RIP version 2 routing updates are suppressed between R2 and R3 using passive interface feature. C. RIP version 2 not enabled on R3. Then D. No issue that is identified. The behavior is normal since default route propagated into RIP version 2 domain by router 1. Now let's go with the network topology and let's examine R2 configuration. So let's just close forwarded to R1 instead of R3. So let's see here. As you can see here, the routing protocol used in router RIP is correctly endorsed. That's all the networks that you will endorse. And then let's see with the R3. Let's check with the routing protocol use. Show run. And as you can see here, it doesn't form any neighbor adjacency because R3 doesn't have any routing protocol use. So if you're having a hard time with the show run, you could just use show IP protocols. So as you can see, it doesn't display any routing protocol use in this one. So in that one, let's go with R2 and let's use the command show IP route because it doesn't send any traffics to R3, and we can conclude that there is no network going to R3 because R3 configuration, as I have displayed earlier, it doesn't have any routing protocol used. So we can conclude that the answer for this is letter C, RIP version 2 not enabled on R3. And here it is, the explanation for that one. Question 4. What is the correct statement below after examining the R1 routing table? So A. Traffic that is destined to 10.10.10.0/24 network from R1 LAN network uses static route instead RIP version 2 because a static route AD that is configured is less than the AD of RIP version 2. B. Traffic that is destined to 10.10.10 network from R1 LAN network uses RIP version 2 instead of static route because a static route AD that is configured is higher than the AD of RIP version 2. C. Traffic that is destined to 10.10.10 network from R1 LAN network uses static route instead of RIP version 2, but the traffic is forwarded to the ISP instead of the internal network. D. Traffic that is destined to 10.10.10 network from R1 LAN network uses RIP version 2 instead of static route because the static route AD that is configured is 255. Now let's go with the topology and let's open R1. So configuration of R1. So let's first type. Now let's look at the network topology and examine the routing table of R1. So here it is, R1. Then just type enable and then show IP route. Now we're looking for the network of 10.10.10.0/24. So as you can see here, the 10 network is passing by 172.16.14.2. So it means that, as you can see here, there is an R. It means it uses the routing protocol RIP. Now, You might be wondering because the statement said it's all about static route and the RIP version 2. Now, if you could see here in the routing table, since it's R, although it says in the question that what could be the statements that will match the question. So let's try to show the whole configuration by typing show run, and we can see the whole configuration in here. AD is configured. Conclude that B is the answer. From this one, you can conclude that if this router or if the network 10.10.10.0 specify that the static route passes will be 200, you can declare the AD in the IP route. So that should have the S. But since a static route value is 200, you have decided that you wanted to put the administrative distance into 200, you can declare that one. And the RIP version 2's AD is only 120. That's why here in routing table of R1 it uses R even though it declared a static route, because the lower the AD, that will be the best path used by the router to pass by to get to the destination of the network. So the answer for this would be letter B. And that's it.